next part of our problem now, our switch has been closed for a very long time and we'd like to see the reading on the ammeter. So what does the ammeter read after the capacitors have had a chance to get all charged up? So let's do a redraw of our circuit and let's figure out what does it mean that it's been closed for a very long time. So we've got our battery, our switch is closed, goes to the ammeter, the 15 ohm resistor, and then up here we've got our 15 microfarad capacitor. We've got our 25 ohm resistor. Then we've got our 75 ohm. Then we come down here, we've got another capacitor, 20 microfarads, 50 ohm resistor. Then we've got a 25 ohm resistor and another 25. And then our 10 microfarad capacitor out here at the end. So closed for a long time means that the capacitor is fully charged. If it's fully charged, it doesn't take any more charge, which means no charge flows through the capacitor anymore. It acts like an open circuit. So switch closed for a long time. Means that the capacitor is fully charged. If it's fully charged, no more charge flows. It acts like an open circuit. Or a broken circuit or an open switch. So right here, and right here, those are all open circuits. So let's redraw what it looks like if we take out those open circuits. And even why don't we sketch through where the current is going to flow. So the current's going to come out of the battery, gets to this point. This is an open circuit. It can't flow here, so it will come up through here. Comes back down, along through here. Can't go through this branch because that's an open circuit. Comes to over here, then it has a choice. It won't go to this branch because that's open. Open means infinite resistance. We'll come down here, here. Again, it gets to a branch. It won't go up here because that's an open circuit. Comes around and finishes the loop. So there's the path our current takes. So this is actually just a simple circuit with a bunch of resistors in series. Let's redraw that and we'll just straighten out that wire and make it straight. So we've got a 25, a 75, a 25, a 25, a 15, and our ammeter. So all these guys are in series. We can find the series equivalent by adding up all those numbers. Our equivalent equals 75. Oh, did I mess that up? Oh yes, that one should have been 25. So this is a 25 ohm resistor. There, that's all straight now. So our equivalent is 25 plus 75 plus 25 plus 25 plus 15. When we add all that up, we get 165 ohms. Let's redraw that equivalent circuit. So we've got a 100 volt battery in series with a 165 ohm resistor. We've got our ammeter down here in series too, our 100 volt battery. Now we can use Ohm's law, just like we did in the last part. V equals IR, so I is V over R, 100 volts over 165 ohms. And this time we get a current reading of 0.606 amps. Okay, so that's the current reading with the switch just opened and opened for a long time. If you try to think about how to do it in the middle, that would get a bit complicated because you would have to think about the charging rates for all those capacitors, and that might be a harder problem to tackle.